Hello everyone, welcome to APS Deep Academy and this is your mentor Swati Joshi. From today we are starting our course on Basic Electronics. Basic Electronics is B.Tech first year course which is majorly common to all branches. The objective of this course are, after doing this, you will able to understand how electronic devices are working and what are their real-time applications. As a part of syllabus, we will discuss semiconductor materials and their properties, p-n junction diodes and their applications, bipolar junction transistors BJT and their VI characteristics, field effect transistor FET and their VI characteristics, and metal oxide semiconductor field effect transistor MOSFET and their VI characteristics. Okay, now let's begin with the class. Electronic devices play a major role in our lives nowadays. Our mobile phone, tablet, laptop and so many other electronic devices which we use on daily basis. Not as an engineer but as a common man, everyone wants to know how these devices work and in which principle they are working and from which material they are made up of. So, isn't it interesting that you are studying it in your engineering? I must say yes. Okay, now before I give you the definition of electronics, let me show you one diagram here. Consider this is a copper wire. And if I connect it with some electricity or voltage, then the electron inside this excited and start flowing in a particular direction. So the flow of this electron is considered as electric current I. Electronics is nothing but to study this flow of electron and manipulate these electrons to perform a specific task. What electronic devices do, they just manipulate this flow of electron and perform a significant task. Okay, as a part of definition, we can say electronics is electron mechanism. It is a science and engineering field which deals with the motion of electrons under the influence or applied electric field. Now we have two terms, electrical and electronics. Are they both different? Yes, they are. Electrical devices majorly use electrical current or electricity to perform a task, whereas electronic devices just manipulate the flow of electrons. See these differences in detail in this chart. Now in this chart we can see that there are so many differences between electrical and electronic devices are given. We will start with operating principle. Electrical devices primarily convert electrical energy to other form of energy. Now with an example we can understand that in an electrical device or a water geyser, let's say, we are giving electricity to water geyser and it is giving us boiling water in the form of heat. So it is converting one form of energy to other form, electrical form of energy to heat form. So this is electrical device. Now if I talk about electronic device, they primarily control the flow of electrons to do a task. Let's say in a bipolar junction transistor, what we are doing, we are regulating base current and accordingly we have different emitter and collector currents to perform the task. Okay, now think an example of an water tap. If I open the tap, then the flow of water is increased. If I close the tap or I'm doing this slowly, then the water flow, I can manipulating the water flow according to my frequency of moving this tap. So if I moving it slowly, then the water is flowing slowly. If I moving it fast, then the water is flowing fast. So this is the main purpose of electronic device, that how they can manipulate the flow of current with these kind of switches. BJT is a simple transistor which can be used as switch also. So BJT can be used as switch also. So this is the meaning of the operating principle of electronic devices. Now materials. Electrical devices use metal and semiconductor, but majorly we can say metals. In electronic devices, metals and semiconductors again, but majorly we can say semiconductor. We will discuss this why semiconductor in this class later on. Now the current, electrical devices use alternating current, whereas electronic devices use direct current. Okay, let's see in your mobile phone charger, it is electronic adapter we can say, but we plug it into socket in our home and in our home AC supply is coming. So to perform this task of an adapter, we must need the AC to DC conversion inside it. So electronic devices always work on direct current, not on AC. Okay, we need a converter here. So power consumption is more in electrical devices and less in electronic devices. If I talk about voltage, electrical devices are high voltage device, electronic devices are low voltage device. They work on 0 to 12 volt. Now manipulation of data, electrical devices do not manipulate any kind of data, but electronic device manipulates data, as we can see in digital electronics, information theory and digital communication. Okay, now required space, electrical devices require more space and electronic devices require less space. If I talk about safety, electrical devices are less safe and electronic devices are more safe. If I talk about uses, then electrical devices purely do mechanical work, whereas electronic devices do amplification of signals, coding and decoding related work. Examples of electrical devices are transformer, heater, torch, hair dryer, etc. And electronic devices are transistor, diodes, microprocessors, etc. Now, I hope you must understand all these differences in detail. Now, let us discuss another topic. Before I discuss another topic, I would like to show one figure again. This is the simple structure of an atom, and in outermost shell there are few electrons. We know that electron carry negative charge and proton carry positive charge, and they both charges attract each other. According to their attraction force, we have three kinds of material possible. So our next topic is types of material. If this attraction force, electron proton attraction force is very high, means this outermost electron does not want to move outside. It does not want to leave its shell and move and take part in conduction, then these materials are called insulators. With very high resistivity and very low conductivity, insulator conductivity is very low. So what is resistivity and conductivity? Rho is our resistivity and it is inversely proportional to conductivity. Conductivity is your mu. Okay, resistivity is rho, conductivity is mu. Okay, now if this attraction force is very less, means this outermost electron wants to jump out and take part in conduction, then these materials are called metals. Very high conductive, very low resistivity. And if this electron has moderate attraction, means this electron want to jump outside, but when I give a certain amount of energy to this, then it will move out and take part in conduction. Then these are called semiconductors. Means conductivity lies between insulator and metals. These are semiconductors. Now we will discuss all three in detail with the help of energy band diagram. Okay, let's energy band diagram. Okay, when this valence band and conduction band overlap, means valence band and conduction band overlap, no much energy required to an electron from jump from valence band to valence band to conduction band. It is jumping. here to here without any external input. So these are called metals, where the Eg or the electronic energy band gap is 0. Okay, Eg is 0, means conduction band and valence band are overlapping each other. So the conductivity of metals are, we know, very high, and the resistivity of metals are very low. So the resistivity of metals are near about 10 to the power minus 2 to 10 to the power minus 8 ohm meters. Clear? Now second we will discuss insulators. Energy band gap here is greater than 5 electron volts, means at least 5 electron volts needed from this valence from electron, at least 5 electron volt needed from jump from this to this band. Electron need at least 5 electron volt from jump from valence band to conduction band and start parting and take part in conduction. But this is very high energy. We can say insulators are very bad conductors because the process here which I explained, that electron need 5 electron volt from valence band to conduction band, we do not apply that much energy to an insulator, because insulator has so many other applications also, so it doesn't part in conduction. If I talk about resistivity, insulators have very high resistivity, 10 to the power 11 to 10 to the power 19 ohm meter. So electron in outermost shell doesn't have that much energy which can take part in conduction. So insulators are very bad conductors. Okay, this I think it is not showing to you. I will write it here. 10 to the power 11 to 10 to the power 19 ohm meter. Clear? So now our third term is semiconductor. Okay, now this is our semiconductor energy band diagram of semiconductor. This energy band gap Eg is at least 3 electron volt in semiconductors. So semiconductor have moderate conductivity and moderate resistivity. So conductivity for semiconductor, resistivity for semiconductor will be 10 to the power minus 5 to 10 to the power 6 ohm meters. Clear? So in these diagrams, we can see that insulators have very less probability that its valence electron, पहले तो valence electron होते ही नहीं, there are very less electron in valence band, so valence electrons are not available in valence band, they are too much tightly bounded with the atom, so very less electron in valence band, so and very high power needed, very high band gap energy needed to reduce this to bond and electron and take part in conduction. Similarly, in semiconductor, we need at least 3 electron volt so that this electron break its bond and take part in conduction. Okay, now for today's last topic is, as I tell you earlier that in this class I will tell you why we use semiconductor, not metals, to make electronic devices. So this is our last topic for today's class, that why we use semiconductors. Why semiconductors? To make electronic devices. Okay, for this again I have to show you few diagrams. Here let's say with blue I will draw. This is an atomic structure of silicon with 14 atomic number, and this is the atomic structure of, let's say, copper with 29 atomic number. Okay, for silicon there are 4 valence electron in outermost shell, and for copper 2, 8, 18, okay, 1 electron in outermost shell. Okay, now see here, this silicon atom has +4 attraction part towards the nucleus. This is not the charge over electron, because electron has negative charge particle, we know that. This is the attraction force toward the nucleus, which is +4, because 4 electrons are in outermost shell. So the attraction force towards the nucleus is +4. Whereas in copper, the attraction force towards the nucleus is 1. Towards the nucleus is 1. It means this electron has more tendency to lose its outermost shell fast than this. It means silicon atom is more tightly bounded rather than copper atom. So metal has unstable structure due to this electron. If this electron lose, we can't manipulate the current that much, but in silicon we can do. Why? Because the attraction force is little high than copper. Okay. Now second thing here is the outermost orbit of this silicon is third shell. I think 3, 2, 1. So this is 3, 2, 1, 1, 2, 3. Outermost shell is in 3 number, whereas in copper it is in 4 number. 1, 2, 3, 4. So the second thing which we have to consider is farthest farthest the electron has highest the probability to lose its shell. farthest the electron जितना दूर होगा उतना उसकी probability होगी कि वो अपना जो है शेल को जल्दी छोड़े. तो farthest the electron has more probability to lose its outermost shell. It means at high temperature, very high temperature, we can't use metals as making of electronic devices, because when trillions of transistors are there, no, the temperature will be high. Laptop garam ho jata hai, any electronic device heaten up, even your mobile phone heaten up. So at high temperatures, this copper will create very disturbed output, but this silicon can stabilize this. So silicon, we can manipulate current better, we can use it in very high temperature because of these reasons, that the outermost electrons is moderately bounded with the nucleus, whereas in metals the outermost shell electron is loosely bounded. And second one is, we can consider it that farthest the element from nucleus has more the tendency to lose its energy or shell fast. Okay, now today what we discuss what electronics is, electronic and electrical differences we do, types of material I explained in detail. After that we will discuss the energy band diagram of all three type of material. Then we discuss why semiconductor we are using. So if you have any query regarding any of the topic, write in comment section. And if you like this, like, share and subscribe. Everybody say, I also say. But teaching is my passion, I love to teach. So this is meditation for me. Teaching is meditation for me. So I am making these videos for my satisfaction. If you love, then join me, subscribe me. Okay, now today I think I am done with today's class. See you in next class. Okay, bye.